So let's talk abstracting behavior, right? This is the last topic. And what we have to remember is that we're going to create objects and we're going to create hierarchies. But there are going to be cases where we're going to need to create something knowing that it's going to exist, and we're going to know most of the interface, or maybe even all the interface that we want to provide, but maybe not necessarily the internals of how the object works, right? So let's take a look. Let's imagine that we have something that's like a payment, right? And we're going to want to create something that processes payments. We've already created stuff like this. We've created a credit card and a chip credit card, right? Payment could be the super type to those. But we could have lots of different things, right? We could have our credit card and our chipped credit card. But we could also have things like cash. We could have a check. We could have digital products, right? And by that, I mean things like PayPal or Venmo or Zelle is a product that's out there, I know, right? And how these things work internally might be a little different. You know, what a balance represents on a credit card is going to be different than what a balance represents on cash, right? We could have balance being, hey, this is a $20 bill, which is different than the balance here where it's like, hey, this is how much you owe on the credit card. So we know that we're going to want our balance, but we might not know how that internally works. Okay. So we can come through and we can see that we have our, that we're going to have a payment, right, with an amount and a method and all this stuff, right? And we went through this. So we're going to implement certain specific methods without offering a behavior, right? Rather than going, well, I don't know what charge looks like. We're going to say, hey, explicitly, we don't know what charge looks like. So we're just going to roll with that for now, right? Down here, we've got charge for credit card, but for our base payment, we may not know. So let's just roll with that and let's see how this works. So we can create what's called an abstract class. And these are classes that cannot be constructed. Specifically cannot be constructed, okay? Certain behaviors in the abstract class will be abstract. They will not be defined. So we can do this many ways in Python, if we're being honest, but we're going to specifically use this methodology where we're going to import from lowercase abc, right? We're going to say from lowercase abc, import capital ABC. And by the way, these ABCs stand for abstract base class. And this thing called an abstract method. And then we're going to define class, name, and remember the parentheses mean we're inheriting from. This is the superclass. So ABC is going to be our superclass. Cool. And then we go about our business and we define what we need to, including potentially a constructor. We might want to define a constructor because even though we're never going to be able to call it, we might define instances we would want to use in other methods. And so they have to exist. So we go through until we define our methods as we would, right? Define things that we can. And then we get to an abstract method. And these are methods with a signature but no implementation. So the signature is the name and the parameter list. In other languages like Java, it would also include things like return type. Python does not specify return type, so that's not part of our method signature here. But you can see, we just say, hey, name of our method, here's what it expects. What am I going to do? I ain't going to do nothing. Pass. I'll deal with it later. Okay. But then we also say, by the way, we put this text decorator up here at abstract method, and this tells the interpreter, hey, this pass, this is not what I want it to do. I just got to put something there. I want you to know that this thing is not implemented, and any class that inherits from this guy, not from this guy, any class that inherits from this guy must implement this method. And if it doesn't, it's broken. So let's do one more. Let's do one more example, and we're going to do a payment. Okay, we are going to back solve. We're gonna retroactively put the payment into our hierarchy. So we have our credit card class again, and we have our payment. Okay, so step one for our payment object is we're going to say from, I don't know why that happened, from ABC import ABC and abstract method. Cool. Now we come down and we say class, okay, class. What do we want to call our class? We want to call our class payment. We want to inherit from ABC. This is not an option. Okay. Now we go through and we start defining our methods. And remember, even though we cannot use this, right, as a true constructor, we need to define it because this is going to establish existence and scope for other variables going forward. And we're going to see how this looks. So we're just going to say that this object doesn't take anything. And the whole thing that this is going to do is give a balance. This is going to encapsulate the balance behavior. And that's it. So we can create this instance variable here. Okay. And this will get used because, hey, we have a balance. Hey, we can create our get balance. We can still do it. And we'll just return the balance. Now, you're going to say to yourself, but what's the point? It's always going to be 0. Yes, for the payment object, for the main superclass, that balance will always be 0. But remember, we're not using this class. We're using this as a basis for future classes, like, say, I don't know, our credit. Okay. And you can see I am backloading the payment into my credit card object. Sometimes this happens. A lot of times your abstract class will be designed first. Okay. But sometimes you realize, oh crap, I need a super type. Let me put this together and push this in. Okay. So now we've got our credit card payment. You know, credit card as a type payment. Well, payment holds the balance. So I don't actually need to do this here because this would be redundant. So I can take this out. And I can call here super.init and that will declare our self.balance. And this is totally legal, by the way. This call is cromulent. This call is fine. But then we come down here and we go, and I forgot to put this in there, and I forgot to spell return correctly, but you know. Okay. Get balance is already implemented. We don't have to worry about that, right? But now we have charge. Now we have charge that we have to worry about, right? And we're going to have charge here. We know that we want something. But let's think about it. How charge works for a $20 bill versus a credit card versus a Venmo is going to be very different things, right? The balance is going to mean different things in these different classes. How it works internally is going to be different. So rather than fudging something and putting something here that is designed never to be used and is broken from day one and is only going to cause errors, we say, you know what? Nuts to this. Pass. I'll deal with it later. Right? Remember, the concept of abstraction is deciding what you need to do now and what needs to be passed on to lower levels. Right? What can be abstracted to a more detailed plane. But we're missing something. And we're missing this text decorator that tells the interpreter this thing is broken on purpose. And if our subclass doesn't implement it, then they've done something very wrong, and yell at them. So let's see how this works. And assuming everything is spelled correctly, right? I run this and it pops right up, right? And we can check payment, right? We can just type payment and we can see it is a class. So far, so awesome. And we're going to say pay one equals payment, and we're going to construct one, and it's wrong, right? Did I spell it wrong? I did. Take two, still red letters of doom. But notice it says can't instantiate abstract class payment with abstract method charge. So this is what I'm saying when I say that the constructor is illegal to be called. And this is why, by the way, this is the initializer, right? Distinction without a difference, right? This is part of the reason why this is legal. So cool. Okay. Let's suppose we do this. Let's suppose that we implement credit card and we import payment and we overwrite it, we extend it. Let's see what I do wrong. I do this every time. Don't feel bad, guys. Even the pros miss a colon. So take two. Run. And look at that. We look good. And we can say credit card. It shows up. CC1 equals credit card. Look at that. Tooltip shows up. Customer is Brian. That's me. Bank is the bank. My account number is 123, and that is my actual account number. If you go and say, I would like to access Brian's account, and his number is 123, they will say, yes, sir, here is both dollars he has in his bank account. And his limit will be $100. Hey, look at that. We get the same error that we got in payment. Can't instantiate abstract class credit card with abstract method charge. Because we said, hey, we don't know how to do this, but we do know that we want every class who inherits from me to do this. So let's put this guy back in. And let's make sure that I get that colon. And let's save it and let's run it. And it runs again. And we call this now. And look at that. Works just fine. CC1 dot get balance. It helps if you hit the keys that you want. balance works. CC1 dot charge $10. CC1 dot get balance. Okay. So by doing this, we can define superclasses that do some of the heavy lifting and then say, you know what, for the things that I don't know how to use, I'm not going to bother. Right? But keep in mind that this is possible. Let's imagine get balance had a fee. Let's imagine that every time you checked your balance, there was a 50-cent convenience fee. You can do this. This is legal because charge exists. Anything that is a payment will have a charge method. And because of duck typing, right, it's going to look for the most specific instance of charge, and then it's going to go to the next level and look for the most specific instance of charge, and it's going to keep going up the tree. Well, because of how we've defined this abstract method, anything that is a payment will have a charge. And so it will be able to handle this functionality. This might not make sense in the paradigm that we were talking about, like, oh, looking at the $20 bill makes it worth $19.50. That doesn't make a whole lot of sense. But to give you an idea from the credit card standpoint and from just the raw functionality standpoint, even though charge is not defined at this level, we can say, hey, I know that charge is going to be needed here. And I can say, cool, that's saved. Let's run this. All right. Get balance. Hey, it's 50 cents. Hey, it's $1 now. Hey, now it's $11.50. This is terrible. I need to close my account at the bank, right? I bring this up to say that that higher level logic is going to be very useful in real world problems or in problems that you have to do for, say, lab 1, right? You are going to have methods that you don't know how to implement in lab 1, that the specification says, hey, we don't know how to implement this at this level, but that you're also going to have to be able to call in order to complete certain behaviors, right? So this is abstraction. This is abstract classes in Python specifically. Each language has its own equivalent of this, and the syntax changes. But most modern programming languages have something that will, especially the object-oriented kinds, obviously, that will allow you to define an object in a hierarchy where you only partially define implementations, and all other aspects are simply interface placeholders for later use. So if you have questions on this topic, please do reach out. Happy to answer it. I know that this is your kind of toughest conceptual part of this module, is understanding the why and the how of this, while still incorporating all the aspects of object-oriented development.